pride, we're going to find the area of these different shapes. I'll just remind you that when we do our conversions, because we're dealing with squares, we're actually going to take the usual numbers. So kilometers to meters is times 1,000. But square kilometers to square meters is times 1,000 squared. So that's where things get a little bit more complicated. 1,000 times 1,000, 1 million. So all of those are just going to be squared because we're finding the area. Area always comes out as something, whatever the unit is, squared. So here we've got a bunch of different shapes that we're going to go through. I'm going to go and do them, and then we'll come back and refer to each of the formulas. But they're very important that we know them. Convert the following area measurement into the unit given in brackets. So we're going from millimeters squared, or square millimeters, to square centimeters. So if we go back and refer from millimeters squared to centimeters squared, we're going to divide by 10 squared. And 10 times 10 is 100. So we're going to divide by 100. So 500 divided by 100. Oh, look at that. That gives us 5 square centimeters, right? Divide by 100. It's that simple. For this one, find the area of each of the following. So area is the area inside. So for this one, we get length times width. 7, or, doesn't matter which one, times 1.5, or 1.5 times 7. And that gives us our area equals 10.5 centimeters. And what kind of centimeters? Centimeters squared. Now we have a triangle. So let's just remind ourselves about the area of a triangle. So a square is side squared or length squared. A rectangle is length times width, and a triangle is 1/2 base times height. And you could write 1/2 base times height, or you could write base times height over 2. It does not matter. So the base, let's call it 12, times the height, you can see there, that's that 90-degree angle, is 4 times 2. And we're going to take half of that. So my calculator tells me that that is 50.4 over 2. So our area equals 25.2 meters. What kind of meters? Meters squared. So this area, that looks like a parallelogram. Let's go and check. A parallelogram is not 1/2 base times height. It is the whole base times height. How magical. So could be easier. Base times height. 9.2 times 4. Our area is equal to 36.8. 36.8 what? Square meters. Find the area of these. All right, we've got a kite. So the area of a kite is going to be equal to, let's have a check here, 1/2 of x, which is really this, times y, which is this. So it's the diagonal connecting the points. So it's going to be 1/2 of x times y, or x times y divided in 2. It's the same rigmarole. So 4 times 6 over 2 is 24 over 2. So our area is 12 what? Centimeters squared. This one, trapezium, this one's a lot of fun. Okay, let's go up and check it. So a trapezium is 1/2 of this side plus the other parallel side times the height. Hey. Here we go. Area equals 1/2 a plus b, which is the two parallel sides, times the height. Or a plus b times height over 2. Same thing. So a and b are 3 plus 11. And the height here looks like a 9er. We're going to take 1/2 of that. So 3 plus 11 is 14, isn't it? Times 9 over 2 equals, I'm just running out of space here, 126 over 2. So the area is equal to, divided by 2, 63 meters square. Now we're dealing with circles. All right, so we got a new one for circles. The area of a circle is, here we go, area equals pi times the radius squared. So different than 2 pi r, which is the perimeter. So this is pi times the radius squared. So, and for this one, it says, using the given value for pi. So we're going to use pi 22 over 7 times the radius squared. We're going to do that first. I'm going to square that radius, 8.3 squared, Mr. Calculator. Okay, so that is 22 over 7 times 68.89. I'm not doing any rounding yet. I'm going to do 22 ABC 7, and that gives us the area is 216.511, and it goes on and on. So I didn't round before, I didn't really have to, but now at the end I round to 2 decimal places, so that 1 is smaller than 5, so that's it, kilometers squared. And finally, the area of this sector, so the area of the sector is going to be, let's go and check it, we'll just check it. The area of the sector is going to be, surprisingly, theta over 360, which just means, what's that fraction of the circle that we're getting the area for, times the formula for the whole area. So this one is a special circle, a version of a circle, so this is a semicircle. So it's going to be theta over 360 times pi times the radius squared. Well, I say that's a straight line, so that's 180. 180 over 360, we know that this is a semicircle, times pi times 10 squared, which you probably can figure out is 100. So we're finding the area of the sector, and we're rounding to 2 decimal places. So I'm presuming then that we have pi times 100, because that's pi times 10 times 10, over 2. So I could start canceling and stuff, but let's have a good time. So 100 times pi, where are you, equals, and I leave that big long number in there, and I divide that by 2, and so our area is equal to 157.079 onward, some things, but I'm going to go and round to 2 decimal places. Because this critical digit is bigger than 5 or bigger, that means I'm going to round that 7 up to an 8. My units are centimeters, and because it's area, they're going to be square centimeters.